Well, my presentation at the meeting really focused on understanding how surface properties are important for pharmaceutical materials, particularly the surface energy of pharmaceutical materials. One of the things we've learnt using inverse gas chromatography over the last 10 years is that surface properties of pharmaceuticals is a really important area, and we've discovered that things such as powder flow, powder milling and powder cohesion can all be studied if you understand the surface properties of the powders, and specifically if you know about the surface energy of the powders. So my presentation talked about how you could measure the surface energy of powders, pharmaceutical powders to be precise, using inverse gas chromatography. And then we highlighted how powder flow, powder cohesion, and indeed the milling of powders can be directly related to the surface energy of the powders we've actually got.
Determining the surface energy of the natural fibers will enable us to check the affinity with a certain type of matrices. So basically, to design a new biocomposite material, we need to get access to this kind of information, to this data. And the classical technique that exists, like contact angle or other known technique, are not that suitable for natural fibers because these are much more complex material with a non-homogeneous structure. So iGC is a technique that enables us to access data that we couldn't access so far. However, as any new technique and a new application area, we have to face challenges and issues to get confidence in our data, etc. So, if now we wonder why is it interesting, why this technique has a potential? Well, biocomposites are materials that are really booming on the market. Industries are keen to surf the green wave. We want to design green components. We want to use renewable raw materials that are really cheap. And the natural fibers are really good candidates for that because they are usually considered as agri-waste, which means they are cheap when they are not free, right? So there is argument for, in terms of money, in terms of new design, we want to be creative, we want to diversify the product on the market. So that's really interesting for biocomposites.